Let's look at how to read a micrometer. So here is a little model of a micrometer that I made. And how a micrometer works is you spin the sleeve here. As you can see, this part is spinning, and as it's spinning, it's moving oh so slightly off to the right. When I'm spinning in this direction, you can see it's moving like that. And as it's opening up, or as the sleeve is moving off to the right, this gap here is opening up. If I was to kind of jump this ahead, do it a bit faster, you can see the two are linked together like that. Alright, so let's look at how we read the micrometer. This is kind of what the micrometer, what the scales look like on the micrometer. The primary scale is this one here. So we're reading in this direction, and this particular micrometer, the one I made this model over, it only opens up to a grand total of about 1 inch. And actually, I didn't make this one big enough. Or rather, I should have made things a little closer together. I ended up making them a little farther apart to make it easier to read. This actually doesn't even go out to 1 inch. This goes out to, what, 0.6 inches there. If I go a little bit further, you can see there's 0.7 inches. It goes almost to 0.8 inches. In any case, this is distorted a bit, so it's easier to read. But this is 0 inches. This is when they're touching. If I was to scoot it all the way over that direction, then you can see it's closed, and as I start to spin it, the gap opens up here. Alright, so in any case, when we're reading this micrometer, there are a couple of different scales that we need to read off of it. And also, when I'm asking questions on the homework and on the test, I will be breaking it up into a couple of individual little readings, so that you're not just telling me what the overall reading is, and if it's off at all, you get the whole thing wrong. I'm not a big fan of that. I want to be able to give partial credit. And it makes sense to me on a question like this. Partial credit would be each of the individual readings. So, the individual readings. First off, which tenth of an inch were passed. If we passed the 0, the 0.1, the 0.2, the 0.3, or so on. Let me just choose a spot. Let me go a little bit further. Well, actually, where I am right now, you can see I'm past the 0.3. So this, oh, right. Okay. So where I am right now, I'm past the 0.3, so my tenths place would be, my tenths place reading would be 0.3. The next reading you'd want to do is, well, since these are tenths, and you can see we're splitting the tenths into individual fourths, each of these readings would end up being a 40th. So off the tenths scale, I don't know why I wrote 1/8. Off the tenths scale, let me just get rid of that, our reading would be 0.3. Off the 40th scale, that's the next kind of reading. Well, this would be 1/40th, this would be 2/40ths, this would be 3/40ths. Instead of writing it like that as a number of 40ths, so it's actually easier to write it as, or to look at it as decimals, because ultimately we're going to want all these as decimals. So the decimals there would either be 0.025 for 1/40th, 0.050 for 2/40ths, and 0.075 for 3/40ths. The way you can kind of remember these is, notice this is 1/4, 2/4, 3/4, except we're adding on the 0 in front of that. So this particular reading that I'm looking at right here, we're past the second hash mark, the second 40th there. So this would be 0.050. That's what my reading would be for the 40th scale. Alright, so the next scale actually gets us down to the nearest thousandth of an inch. And the next scale is this, this scale that you can see on the sleeve here. On this scale we have a 0. Oh yeah, whatever. You can see my you can see my writing as I'm rotating. Whatever. So you can see there's a 0 here, and as it counts up, there'd be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this goes all the way around the tool, all the way up till 24. So here's 20, 21, 22, 23, 24. And so what this does is one complete revolution of, one complete rotation of the sleeve will get us 25 thousandths of an inch. That is 1/40th of an inch. So that this is actually our next scale. And to read this scale, we need to look to see where there's this horizontal scale here, and where it crosses our scale, the scale on the sleeve. And so you can see this is the 0 right here, 1, 2, 3. We're past the 3, we're not yet to the 4. So this scale, this reading rather, I would have, the thousandth scale would have 0.003. 3 thousandths. This can go all the way up to, like I said, 24 thousandths on that scale. Alright, and all of this writing is kind of all over the place. Hopefully it's not too bad. Alright, so in any case, I probably should have opened up another window to write that stuff in. Yeah, well, I'll do it in the next one. Alright, the final reading is the vernier scale. And for the vernier scale, it's a little bit weird, but you actually, in order to read the vernier scale, you have to be looking at the rod straight on. So and what we're looking for is where the two lines line up. So if you're looking at this, kind of looks like these two line up. But if I was to kind of come to a slightly different angle, I actually extended the black onto here, you can see they definitely don't line up. You actually have to go all the way over to here. This is the one where they actually line up. It goes like that. And that is, it looks like, right here. To figure out where we're at on that scale, so I have to be careful about rotating now apparently, you would read way over here. It's the 6. So your final scale, let me see if I can get this stuff back so you can read it again. The final scale, we have the thousandths. That vernier scale is the 10 thousandths. And this, I said it was a 6, so this would be 0.0006. And to get the total measure of where all this stuff was, I think that was a 6, wasn't it? All right. This one right here is where it's lined up. Right there. Which is a 6. This is not cooperating. Yeah, okay. So in any case, we get a 6 there for the 10,000th scale. So to find what our overall number would be, we would add all of these individual things up. I'm just going to write it again. We have the 0.3, and we need to add on the 0.050 because we were past the second hash mark there. We're up past the 3, not yet to the 4 on the sleeve scale, so 0.003. And on the vernier scale, we were at the 6, so we'd get 0.0006. Now we'd add all of these things up, and we'd get 0.3536. That would be our measurement to the nearest 10,000th of an inch. All right, let's do another example. Let's come over here. So reading off the various scales, and actually I'm going to give myself a little bit different space to write in so that I'm not constantly messing up where I'm writing by rotating. Okay. So my first reading would be to the nearest, the 10th of an inch scale, and that is, it looks like right here I'm past the 2, so this would be 2/10 of an inch, or 0.2. My next reading would be, I'm past the 1/40th of an inch, so this would be 0.025, 1/40th of an inch. The next reading will be to the 1000th of an inch, and for that reading I need to look at the scale, the sleeve here. Let's see, this is a 10, 11, 12, 13. There's a 13 right here, and I'm not yet to the 14, so this is going to be a 13, so 0.013. I know that this ends in the thousandths place, so it's the tenths, hundredths, thousandths place. That's how I know that this is 13 thousandths. And for the final scale, I need to look to see where these line up. And as I'm rotating this around, It looks like right here is where they line up, and it looks like that's at the 6. Over here, you can see it says 6 right there. And so that would be for the 1/10,000th scale. This would be 0.0006. So adding these all together, we get 0.2, 38, and 6. So that vernier scale is kind of tricky. Let me actually go all the way back here to 0. And let's take a little bit closer look to see what's happening here. So as each time, how I've set this up is each time I advance, it'll be 1/10,000th of an inch. So right here, this is lined up, you can see the vernier scale, it's lined up directly at the 0. This line right here is the 0. If I rotate it just a tiny bit, now it's lining up at the 1. If I rotate it just a tiny bit more, now it's lined up at the 2. And then the 3, and then the 4. All I'm doing here is rotating the camera around so we can kind of see what's going on here. Now it's at the 6, now at the 7, now at the 8, the 9, and at the 0. And once it gets to the 0, it's actually lined up down here again at this 0. So what has happened, let me go back to where I started. I started out right here. And throughout all of this, you can see I'm right here on the sleeve. It's where the 0 is lined up on the sleeve. Throughout those 10 ticks, I ended up right here. That is 1/1000th of an inch. So rotating my sleeve from here to here, that's rotated me by 10/1000ths of an inch, or 1/1000th of an inch. If I did that again, you can see rotating it just a tiny bit more, the 1 lines up again, then the 2, then the 3, then the 4, then the 5, the 6, the 7, the 8, the 9, and the 1, which again lines up down here. And now I've gone 2/1000ths of an inch. So as you spin this thing around, you can see that vernier scale gives us an incredible amount of accuracy. I can tell the difference between it being here and here. So if it's, let's say here, we're lined up at the 0. If it was over here, we're lined up, looks like at the 7. So that would be whatever the other measurement is, 21 thousandths. 21 thousandths of an inch plus 0 versus 21 thousandths of an inch plus 7. So 0.0. The other readings are both zeros. 1/10th of an inch, the reading was a 0. 1/40th of an inch, the reading was a 0. But once I get to the thousandth scale, this was right here was, I can't tell which one of those is lined up. I think it's right there. That would be 0, or rather 21 thousandths. I guess they're both 21 thousandths, aren't they? 21 thousandths, which is 0.00. No, it's not 0.0021. It's just 0.021. And 1/10,000th of an inch. At the 10,000ths of an inch scale, we're talking about a difference between 0 or I think I said 7. I don't even remember what it was at this point. The point the point of all this is to show you how this sleeve moving ever so slightly off to the right, it is moving each time I'm rotating this. It's essentially on a screw thread. Each time I'm rotating it like this, it is moving just a tiny bit. And you can only by moving it, quite a ways can you actually tell that it's moving off to the right, kind of by animating it like this. All right, let's do one more example. Let's come way out here. Let's go there. No, there. Let me see if I can clear that stuff off. Okay, so if we want to read it where it is right here, we first need to look at the horizontal scale. We're past 4/10ths of an inch because we're past the 4 here. So for the 1/10 of an inch measurement, we're past 4, so that'll read as a 0.4. For the 40ths of an inch measurement, oops, actually, sorry, I wanted to be over here. I hadn't done one where we're past the 3/40ths of an inch mark yet. So let's do this one. We're past, again, the 0.4. We're past the third 40th of an inch mark, so this will be 0.0, oops, it's 0.4. 1/40th of an inch was 0.075. For the 10,000th of an inch reading, it looks like we are past, we're at the 5, 6, 7, 8, 9. We've passed the 9, we're not yet to the 10, so I'm going to read that as a 9, 0.009. And for the 10,000th of an inch mark, 10,000th of an inch reading, we need to rotate this a little bit. Yeah, I think it's lining up right here. That's what it looks like to me. And that's at the 1, way the heck over there. So when I'm, this will be 0.0001. So adding these all together, we get 0.4. The 7, 5, and the 9 add together to give me 8, 4, and then I get a 1 after that. So 0.4841. When you're doing these questions on the homework and on the test and the quiz and whatnot, I will give you 2 separate views so that you can actually read these things. The first view that I'll give you will look like, will kind of be oriented like this, where you can read off where you're at on this horizontal scale. You can figure out your 10th, your 40th of an inch, and you can figure out your 1,000th of an inch, all from this reading, this view right here. But for the vernier scale, what I'll do is I'll take and rotate the camera so that we can actually see where the lines are actually lining up correctly. So like this, the second picture would probably be taken roughly like this, and you would want to read the vernier measurement for that one. So this would be 1/1000th of an inch because they're lined up right here. So that's how you read a micrometer. Hopefully this will give you a slightly better idea than just trying to read through it in the book, because this is, you can actually kind of rotate it around. But this actually, these scales, I'm pretty pleased with how close this ended up looking like the original thing, with the exception of the weird texture on that blue. I tried doing something special and it didn't work out. In any case, that should be enough for you to be able to see how to read a micrometer.